Hello everyone. Now let's start with question. So this is the question which I have taken here. y1, y2, y3 has values of y1, y2, y3 in terms of x1, x2, x3 has been given. So y is a function of, basically y is a function of x, that's how it has been given. So what we have to show is Jacobian of y1, y2, y3 at with respect to x1, x2, x3 is 4. So if you find the Jacobian, it should give the value 4. So first of all, we will write the given values or given functions as it is in terms of y and x. So the values y1, y2, y3 we have taken it as it is. Now since y1 is function of x1, x2, x3, y2 is function of x1, x2, x3 and y3 is also function of x1, x2, x3. So what we have done it in first row, we will just pick one function and we will differentiate with each variable. So this is how we got the first row. y1 we have picked it one function and with respect to each variable we have differentiated it. Now I have taken y2 function and the same thing, it's a function of x1, x2, x3. So I differentiated it with respect to x1, x2 and x3, which we will be writing here as a second row. And in third row similarly I have differentiated y3 with respect to x1, x2 and x3. So this is how the determinant, Jacobian determinant will be coming. Now next thing is I have to find each of these terms value so that I can substitute this in this determinant and I can simplify it to get the final value. So here del y1 upon del x1, that's a value we have to find. So here simply y1 is given over here with respect to x1, we can differentiate it. So it will become like this is like 1 upon x1. So this will become x3 x2 upon x1 square. It's simply like 1 upon x differentiation. How do we do it? 1 upon x differentiation will be minus 1 by x square. Same thing here, this is 1 upon x1. So I have taken it, x2 x3 will be constant because we are differentiating with respect to x1. So that's the reason it will become something like this. Now similarly y1 I have to differentiate with respect to x2. So here it will become like with respect to x2 I am differentiating, so it will be x3 upon x1 because x2 ka derivative 1 ho jayega. So that I have written the values over here, and similarly del y1 upon del x3 with respect to x3 I am differentiating. So x3 will be differentiation of x3 will be 1 and I will get x2 upon x1. So this is how first row will come over here by after differentiating y1 with respect to x1, x2 and x3. So similarly we can find y2's derivative with respect to x1, x2, x3 and we will be substituting here in the second row. Similarly y3 we will be differentiating with respect to x1, x2, x3 and we can write it in the third row. So this is how we can get the different values for x1 for partial differentiation for each of these things. This is for y2 and here I have differentiated y2 with respect to x1, x2 and x3. Here y3 I have differentiated with respect to x1, x2 and x3 by using partial differentiation rules. Now the next thing is all these values we have to keep it in the determinant, Jacobian determinant. So here after placing all the values in the Jacobian determinant, which we found it in the first step, so after this it will be something looking like this. After keeping the values of all the values which we found in the determinant, Jacobian determinant, I will get this determinant in this form. Now I have to simply simplify this Jacobian in terms of by using the regular differentiation by regular determinants rule. So here how we do the multiplication is x2 x3 we will take it and we will find the product of x3 into x1 and minus x1 into x2. We will subtract this. How we find this is the multiplication of this minus multiplication of this one, x3 x1 into x1 x2. So this will be like this and it will get multiplied with this one. So if I will simplify this for each of this term, same way I will apply it for each of this term and I will simplify it, the determinant. So finally I will get, and I will take the x1 square, x2 square and x3 square common, putting all the values which we found in the previous step for del y1 upon del x and del y1 upon del x2, and all these values we will keep it in the determinant, Jacobian determinant, which we found in the first step. So then this determinant will look in this format. So after this we have to simplify the determinant by using the rules of determinant, like first this thing, this number we will take it, then we will multiply these two and subtract them, and similarly we will do for rest of the things, like here minus x3 x2 upon x1 square, and we will simply do the cross multiplication of this one, minus x3 x1 upon x2 square into minus x1 x2 upon x3 square minus product of this one x1 x3 into x1 x2. This will be multiplied with this one. So same way for each of this term we will be doing it, and the final value we will try to find it. So by taking out this common x1 x2 x3 from each of these rows, so we will get something like this. Now putting the values from each of the column, then I will get clearly, I can cancel this out, and then again I will simplify this one by using the determinant. So minus 1 I have taken in here, then minus 1 into minus 1, and this one subtraction I will do it over here. So this is minus minus, this will become plus 1, then minus 1, again this minus 1, this 1 along with subtraction sign, then this will be 1 1s, which will be minus 1 over here, and this multiplication of 1 1 will be minus 1. So by simply using the determinant rule, we will be try to simplify this one. So the final value, if you will get it, is as a 4. So this is nothing but the how we found the value of Jacobian matrix, and if you look at the question, that's how they ask us to prove it. The value, the final value for this Jacobian, we should get it as a final result, and that's how we simplified it. The first important thing is how to write Jacobian matrix, and after that simplifying, finding partial differentiation of each of the function with respect to each of the variable, and then after that simple determinant rules we should be applying to simplify it to get the final result. So simply what we have done it, first of all we wrote the determinant, Jacobian determinant we wrote it. The given function we differentiate partially with respect to each of the variable. Then we try to find the value of each of the partial differentiation separately. Then we place the values in the determinant, and then by using the determinant rule we simplified it to get the final answer. These are the simple steps which we followed. We have done the determinant previously in the 11th and 12th grade. If you have good practice on that, then this will be quite easy. As such, only the new concept which is here is how to apply to different variables. Other than the solving the matrix, determinant, and that is the same rules which we will be following as before. So that's the same concept will be here. I hope this is clear to you. Thank you.